All right, so this is our last example. This one is also, it has to deal with trig functions, so it's going to do the whole, when we graph it on our calculator, it's going to be the whole Zoom 6 scenario, okay? Just like the other one, I know it looks like it's more complicated, but it's just like the other one where to go from parametric to rectangular, you're trying to get rid of the trig functions and the t. So you want to get the secant t and the tangent t by themselves. So in your first equation, you're going to add 2 to both sides. So you're going to have x plus 2 equals 3 secant t. And then divide by 3. So x plus 2 over 3 equals secant t. Okay? And then in the second equation, let me switch colors here. Subtract 1, so you get a y minus a 1 equals 3 tangent t. And divide by 3, so y minus 1 over 3 equals the tangent of t. Okay. You use a trig identity, Pythagorean identity. Okay. Specifically, you're going to use the fact that secant squared minus tangent squared equals 1. So you plug in again. It's the same idea. So you're going to do an x plus 2 over 3 squared minus the tangent squared is a y minus 1 quantity squared. I'm sorry, y minus 1 over 3 quantity squared equals a 1. Okay? So you're going to write x plus 2 squared over 9 minus a y minus 1 squared, also over 9, your numbers happen to be the same, equals a 1. That is a hyperbola. That's it. That's a hyperbola. The x is first, so it's going to open left and right. And we've got a center at -2, +1. -2, +1. Remember you take the opposite. So it's x plus 2 and y minus 1, so you're doing the opposite. And then you're going to count out 3 everywhere. 1, 2, 3 to the right. 1, 2, 3 to the left. 1, 2, 3 to the left. There we go. Oh, stop it. I don't want to cut or select that. What are you doing? Stop. It's being weird. And then 1, 2, 3 up. 1, 2, 3 down. Okay. Oh, I counted too many. 1, 2. I counted 4. Sorry. 1, 2, 3 down. There we go. Okay, and remember, hyperbolas, we did that rectangular box, and it's not going to be very nice, so I'm going to have to try to maybe, I'll just highlight it. We'll do it that way. We'll do a very light highlight. So we did a rectangular box, right, around those 4 points, and then we drew in diagonal lines, which I'll draw in light gray. So we drew those lines here. And so basically our hyperbola is going to be, and again, just a sketch is fine. Our hyperbola is going to open left and right, and it comes this way and goes through that vertex and comes this way and goes through that vertex. Now, again, go to your calculator. You just want the direction. You want the direction of this thing. And I'm going to tell you right now that hyperbolas are a little bit harder to watch on the direction. Okay? When you type it in your calculator, remember secant is not on your button list, so it's really just 3 divided by the cosine of t, then minus 2, and then y1 is 3 times the tangent of t plus 1. Okay, and again, this is a Zoom 6er because it's a trig thing. So Zoom 6, you have to kind of watch it. It's weird. It'll do 1/2 of the part of the shape, and then it goes and finishes the other one, and then it finishes that one. So you just have to watch it a little bit. But ultimately, your direction is this. Okay, and it's heading up here because what it does is, and I'll try to show you. I'll highlight it with. We'll go with like a light blue. When you graph it, it graphs this part first, and then it comes around and does this section, and then it comes back and finishes this section. So hyperbola is a little You got to watch them. That's why you like watch your screen like a hawk the second you hit zoom 6.